Hey there, this is example 7 where it's a bit trickier now once you get to the later stage of indices. Sometimes you don't always get the same bases, and what you have to do is you have to break them into their prime factors. So here I would then say 12 can be broken up into 3 times 4, but 4 can be written as 2 squared. So really, I would write this now as, instead, I would write you can write the number 12 as 3 times 2 squared, which gives you 12, and then it's all to the power of n. Multiplied to, and I do the same thing for 18. You see, 18 can be written as 3 squared, which is 9, times the 2, and that will give you 18. So I can write that as 3 squared times 2 will give you 18 to the power of negative 2n. And the reason why you do this is because you can use one of the rules where you can multiply the powers to each other. Okay, so I'm multiplying the powers to each other here, and that breaks up the bracket, so this becomes 3 to the power of n multiplied 2 to the power of 2n multiplied to 3 to the power of negative 4n times 2 to the power of negative 2n. Okay, and the reason why I break it up now is because then you can collect the bases that are the same, and you can then add the powers because they're all multiplying each other. So here you would then have 3 to the power of n plus negative 4n multiplied to 2 to the power of 2n plus negative 2n. And we can see that this simplifies down to 3 to the power of negative 3n multiplied to 2 to the power of 0. So really, it just becomes 3 to the power of negative 3n multiplied to 1, which is the same thing as writing using the reciprocal method, because that's a negative power. So negative 3n can be written as 1 over 3 to the power of 3n. There you go. So that's how you would do example 7. And for B and C, I've got the working solutions there with the same idea. You want to break it into its prime factors.